let's see, Cole and a couple other guys with us. Yeah. Oh, wait, I need my pencil for the iPad. Of course, I can't see anything thanks to my glasses fogging up. This is getting real old. So you guys need to be hurrying up on this vaccine creation thing because I'm tired of this already. So anyway, all right. Let's get to it. Wanted to talk u-substitution stuff, just to remind ourselves how that worked. And let me go to a blank sheet here, and then also open up the sheet for today. I haven't put this up on Canvas yet. I'm running a little bit behind schedule, but I'll put it up after class. So the u-substitution stuff hopefully will be mostly review from um, last time, and let me pull up Twitch on this computer so I can monitor the chat. Hopefully, you guys, the audio is coming through okay. TV I want mute. Okay. All right, so all you've got in front of you right now is just a blank white screen. But what I need is the u-substitution review, and I'll post this file up on Canvas, but I'll just use a blank board for now. Okay, so let's just remind ourselves sort of how u-substitution works. So let's just say um, oops. Right. Why did that happen? Oh, because I'm an idiot and I hit the button. Okay, sorry. All right, so let's say we wanted to find an antiderivative of e to the 5x, or another way to say that right is the integral of e to the 5x, or indefinite integral of e to the 5x. So this one's simple enough that, well, what would the derivative of e to the 5x be? E to the 5x times 5, well, for derivative. Yeah, okay. And the times 5 is there because of the chain rule, right? And so if we think, all right, let's just say we guess, let's just say that we guessed that it was e to the 5x was the antiderivative, okay? Then the derivative of that would be 5e to the 5x, but, sorry, my handwriting is atrocious, but it should be e to the 5x. Okay, so how do we fix it? How do we make 5e to the 5x turn into e to the 5x? Well, factor of a fifth would do it, right? Okay, so the correction is to say, actually, why don't we do this so that when we take the derivative of it, the fifth cancels the 5 that pops out from the chain rule, and we're good, okay? So now in this case, because we were just sort of off by this 1/5 or 5, the constant business, right? That's not that big of a deal, and we could do that relatively easily in our heads. But what really are we doing when we do this sort of thing? We're saying, okay, I'm gonna let the quantity 5x, right? If that were just e to the x, we'd be done. It'd be easy. But it's not. It's e to the 5x. So let me just call 5x a different letter. Okay, that's great. Well, what's the relationship between 5x and this quantity u? I mean, they are the same thing, right? Just because I said so. But if u is 5x, what's the differential du? Yes, 5 dx. Okay, and so if I solve that algebraically for dx, then du over 5 is dx, and that's where the fifth really is coming from. Okay. Okay. So now if I take this and I take that and I substitute them in to the original integral, well, I've got the integral of e to the 5x. That's now e to the u because 5x and u are the same thing by my choice. And then dx, I'm going to say that that gets replaced with du over 5. Okay? Gucci? Yeah? All right. Now that I've got that, then two things I can do. I've got a 1/5 inside the integral, just a constant. Can I say the following? Is that acceptable? Okay. Why is that okay? I mean, it is, but let's maybe be a little bit more clear as to why that's acceptable. Yeah. Yeah. So if we interpret, and the same thing's true about the derivative, right? Is that the derivative of 5 times a function is 5 times the derivative of the function, right? So you can flip it either way. And this is perhaps easier way to see because now in terms of u, we just have integral of e to the u du. Well, that's easy, just itself. Okay. And then so we have now 1/5 e to the u plus c. And then, of course, the last bit of tidying is, well, u had nothing to do with the problem, right? That was an auxiliary tool we introduced. And so we need to go back in terms of the original variable, um, which was x. And then we get our 1/5 e to the 5x plus c. Okay. Um, Now, for something like this, like if we actually had this problem for real or this appeared in um, in the midst of doing some other problem, uh, by the end of next week, I expect you guys to be able to go from here directly to there without having to write any of that stuff down. Okay, for a simple one like this, meaning where it's just e to the 5x versus e to the x, right? Just a simple constant. That's pretty easy to fix. More complicated ones, of course, it's better to write them down. Um, but something simple like this, you know, we got bigger fish to fry, believe me. All right, so let's do something that's a little bit more exotic um, here. Um, so actually, here, I'll let you guys do this one. Okay, so if we were to go through and write it all out, what is this all written out going to look like? All right, so take a minute and write all the steps down, even if you think you know the answer instantly. And same thing, you guys at home. Uh, Looks like we got 3 people tuned in. Uh, Actually, my CS class this morning was great. I had more people tuned in on Twitch than people in the class that weren't in the room. So I had like 13 people turned in on Twitch when only like 7 or 8 should. Yeah. So yeah, so I'm gonna be making all the ad revenue. I'm gonna get affiliate before you know it. It's gonna be great. All right, so Mr. Hoke, I hope I'm pronouncing that correctly. He's got a suggestion here. Uh, I wish I had multiple screens so I could put up the Twitch chat and you guys could see what everybody else is saying. Uh, Oh, now we're up to 5 people. Awesome. That's more than it should be. So maybe people are just like, I really want to watch calculus at 9 in the morning. Farden would be fine. Okay, got it, Farden. I hope that Farden, uh, put the emphasis on the correct syllable. Um, all right, Farden, got it. Excellent. Okay, so let's see what if you guys agree. So Farden suggests that the answer should be this: negative a quarter cos of 4x. Disagreements, agreements. What's the peanut gallery think? Yes. Okay, Mr. Hurt agrees. Mr. Trapp, sounds good. Yeah, you guys agree? Okay, so what would the substitution, if we were to write this out the long way, have been here, right? U equals 4x, du is 4 dx, and etc. So this would have worked very similar to the last one. And then, of course, this will trip you up, especially if it's late at night. The derivative of sine is cosine, but the antiderivative is negative, right? So don't botch that. But yeah, this is why you should never do calculus after about midnight, because nothing good ever happens after midnight. Okay, so let's do something a little bit more fun. Um, so um, how about this one? All right, so integral of sine of x over cosine cubed x. And if you want, right, you could also write it this way. Same thing, just, 6 and 1/2 a dozen of another. Okay, so what's probably the move we want to do here, right? The whole goal with u-substitutions is to find part of the integral whose derivative is the rest of it, up to a constant, possibly. Okay, constants we can fix. Um, and so, any suggestions here for what we should make u? Any suggestions? Bueller, Bueller, sine of x, okay, or cosine of x, right? We really only have 2 possibilities here. All right, so if we try sine of x, thanks, Ethan, for being my patsy this morning. Let's try that. All right, well, what's du? Careful. Yeah, normal derivative, right? Okay, so if I were to substitute that in, then what do I have? This would become, I'd have u over du cubed question mark dx. What does that mean? Okay, so this is what happens if you pick the wrong u, right? It doesn't make sense. Okay, so that's why, thanks, Ethan, for being the patsy this morning. Okay, so that was not the approach. Um, and, if the integral is really nasty looking, then, it or if you're doing this after midnight, you'll probably pick the wrong u, okay? And so let's try it again. So what would be the better move here is to let u equal the cosine, okay? And the reason then is then du is the sine, the term that we had in the top, and it makes sense to talk about du. It doesn't make sense to talk about 1 over du. That's meaningless. Okay. All right. So at this point, what should we do? Let's solve for dx in terms of du. okay? And then if we do our substitution, then the integral is, well, sine x we said was, well, let me actually just leave it like this. I've got u cubed and dx is that, okay? And you might say, oh, wait a minute, this isn't good because I've still got both things in terms of x and other things in terms of u, but what's good here? Why is this not a problem? Yeah, the signs cancel, right? And now we just have it as du over u cubed. Okay, so how should we think of du over u cubed? What's another way to write that? I, yeah, negative, positive. What's a negative sign between friends? Hmm? Yeah. So, yes, the negative. Um, and this preview of coming attractions for the rest of the semester, I will flub minus signs left and right, and so right, this is one reason why it's nice. There's just 5 or well 6 once Cole gets back to campus of you guys physically in the room, and then 3 online, so we can. I got 9 of you guys to like help me not screw up minus signs because they'll just hire anybody to teach calculus here. It's really terrible. Okay, so I'm going to think of this. Um, and Ethan, I'm sorry if I'm going to reuse all the jokes I did from last semester. Yeah. Yeah.
This time at least I'll know if to laugh.
That's true. That's true, right? Because you got practice last semester. So, okay. So think of it as u to the minus 3. And then when we do the antiderivative, right, the power rule, we'll get negative u to the minus 2 over minus 2 plus c. And then the negatives cancel, and so I'll just write it as that. Okay. And, excuse me, then um, what else do I need to finish with? Okay, so I've got, are we cool with the antiderivative there in terms of u? Right, power rule. Okay, now what? Right, so we used u, let's replace it. So our substitution we picked was u was cosine, and so we'd have 1 over 2 cos squared x plus c, or you could write this as 1/2 secant squared if you wished. Same thing, because it's cosine in the denominator. Okay, so either one would have been fine. Okay, good. All right, so let's see, Farden. Yeah, I think if you got the log there, you forgot the exponent that was on top of the cosine. So that's actually the the very next question I was gonna kind of work us through. Okay, so we Gucci with this one? Yeah. Okay. All right, so let's go into one that's a little bit more fun. Um, so that's the worst looking integral sign ever. What's the integral of tangent? Well, what's the trap answer here? What's the, yeah, okay. Secant squared would be the trap answer because you mixed up derivative and antiderivative. Nice, Mr. Trapp. Yes. Mr. Trapp, his last name is Trapp, T-R-A-P-P, and therefore all of his answers are trap answers. Yeah. Well, you know what you ought to do? You ought to start a monastery and brew beer because then it can be Trappist beer. Have you ever heard that one? Mm-hmm. Yeah, Trappist beer is very good beer. Anyway, okay. So how are we going to approach this? Right, the trap answer is secant squared. That's not correct, obviously, because that's the derivative, not the antiderivative of tangent. What do we got to do? Exactly. Okay, we need to rewrite this thing in terms of, in this case, sine over cosine would be a good choice. Okay, and then that makes this problem look similar, not identical, but similar to the previous one. The only difference is that this time we only have cosine in the denominator, not cosine cubed. Okay, however, the same substitution will work on this one. Oops. Okay, so that substitution that we did, u equal cosine x, du is negative sine x dx, and then solving for dx algebraically, that part's exactly the same as the last problem by sort of coincidence. And then let's see, what else do we need here? Actually, to make the substitution. Oops, sorry. So I've got sine x dx over u, and then dx was du over negative sine x. All right, so cancel stuff, the signs cancel, so I've got negative integral of du over u, which is what? What's the antiderivative of 1 over u? Yeah, so we get the logarithm. Okay, and so like so. There is one other way we can write this. What would be the other option? I mean, this is perfectly fine, but there is one minor. Right, because, okay, and so what rule did I use there? The rainbow rule? Ah, that's cute. Okay. Um, yeah, I do. It is. Um, that, yes. That one doesn't roll off the tongue nearly as well as the rainbow rule, right? So, yeah, exactly. So, why this is the rainbow, right, is that what I'm essentially doing is, you know, he moves to, yeah. And you have to have the sound effect too, right? Or it doesn't count. Yeah. Now, actually, I suppose what I need to do is because we're streaming on Twitch, and I got a new toy the other day. I got a little stream deck. I could do like the thing where like glitter and rainbows start, overlaying or something. Uh, yeah, get all the fans excited. Yeah. So, okay, good. So yeah, so that was just one of our rules of logarithms to write it as natural log of secant instead of negative natural log of cosine. It doesn't actually matter, right, which one you pick. Um, so do you like having the negative sign or not? Right? It's just sort of an aesthetic choice. So, okay, the very last thing I wanted to talk about today, and I'll give you guys a couple of extra practice ones, is what happens if we have a definite integral? How does u-substitution work there? So let's say, for example, we had this. Okay, so if I have a definite integral, and I'm going to have to do a u-substitution, then there are two options. Okay, the first one is, what about if I just pretend that this is an indefinite integral, get the integral, and then plug in the two bounds at the end? Right, that certainly would work. Just blow off the problem and deal with it later. okay? The other method is to actually convert the bounds. So what would the u substitution be here? What's probably our pick? We? Okay, good. So if I let u equal 1 minus x squared, then as usual, du is minus 2x dx, and dx is du over negative 2x. Okay, so that part works the same as it would before. But we also have two bounds here, this guy and this guy, and those in the original integral are numbers in terms of x because all the stuff is x, okay? So if x equals 0, then what does u equal? Well, how do I convert between them? What was the relationship between u and x? U was defined to be, for our choice, 1 minus x squared, right? So if I plug 0 into that, what do I get? 1, okay? And if I do x equals 1 into that same formula, what do I get? 0, okay? And so this integral is now turned into the integral from 1 to 0, and yes, I know that seems backwards. And then we've got x square root of u dx over negative, or sorry, du over negative 2x. The x's cancel. Oop, sorry, guys. All right, 1 to 0 of, it'd be what? Root u du. Okay. Does it bother anybody that it's 1 to 0 instead of 0 to 1? Oh, I did. Thank you. Okay. So how can if I'm really bothered by the fact that it's 1 to 0 rather than 0 to 1, can I rewrite it as such at the expense of a negative, right? So I can rewrite this as 1/2 0 to 1 of root u du. Ah, that is terrible looking. Okay, it doesn't really matter. And then when we do the antiderivative here, then fundamental theorem of calculus tells us what to do at the end, right? So the antiderivative here would be u to the 3/2 times 2/3, and then our half that we had out front from 0 to 1. The 2's happen to cancel, coincidentally. And then what does the fundamental theorem of calculus tell us to do with the bounds? The number at the top and the bottom. Plug in the top one. Plug in the bottom one and subtract. And so in this case, we just get 1/3. Okay. So we would have gotten the same thing if we had done the indefinite integral, gotten everything back in terms of x in the end, and then plugged in the 0 to 1 that we started with. There's advantages to doing this both ways. So one advantage to blowing off the bounds until the very end is you only have one thing to keep track of at any given time. You're doing an antiderivative, then you're worrying about the fundamental theorem, right? So it's the odds of making mistakes are reduced because you're concentrating on the two steps separately. There are advantages to converting the bounds like we did here, and that's especially true in context that you'll see in like multivariable calculus, which we'll do a little bit of in the end. Like if you're doing a coordinate transformation, going from like Cartesian into polar coordinates or something like that, then you kind of want to think of that at that time. So anyway, okay, so we'll quit with this, and we're going to do our first fluency assessment today. So aren't you guys excited? Yes. Okay. Will sounds super excited. All right. So those of you guys who are remote today, check your email in just a few seconds, and Print it out if you've got a printer, and if not, just write it on separate paper. And then if you've got a scanner, great, scan it and email it back to me. Or if you've got Cam Scanner or something like that on your phone, you can use that. So, all right, so I'll go ahead and quit the stream. And the four of you that are at home, check your email here in a few seconds. And I will see you guys on Monday, if not sooner.